Hello student, welcome to my channel BK Voice. Today I am going to discuss with you some property of light, and one property of light is refraction of light. Now you people know that the velocity of light is maximum in air in vacuum, and its value is 3 into 10 raised power 8 meter per second, and its velocity in water is 2.25 into 10 raised power 8 meter per second. Its velocity in glass is 2 into 10 raised power 8 meter per second. Now what happens when the light passes from air or vacuum to other medium? Its velocity, its speed always changes. The change of speed takes place. And the medium in which the speed of light decreases is known as optically denser medium. A medium in which the speed of light decreases is called optically denser medium. Suppose you are having two medium, light is moving from medium number 1 to medium number 2, and its speed decreases in medium number 2, then I will say that medium number 2 is a optically denser medium. By its speed, velocity, the speed of light is decreasing in this medium. And if the speed of light increases in that medium is known as optically rarer medium. So optically denser medium is there, that medium in which when the light passes its speed decreases, and optically rarer medium is that medium in which the speed of light increases. So that is there, keep it in your mind. Now next thing I am going to discuss with you is the refraction of light. What is refraction of light? That I am going to discuss with you. Now refraction of light, see here beta. Now if this is the surface which is separating the two medium number 1 and medium number 2, and a ray of light strike it over here, this ray, as you know, is known as incident ray. If I draw the normal, the ray should pass straight, but you will see the ray of light will not move straight, it will change its direction. This is the refracted ray. There is a change of direction, and this change of direction of ray of light when it passes from first medium to second medium, or from one medium to another medium, is known as refraction of light. What is refraction of light? Refraction of light is the change of direction of path of the light when it passes from one medium to another medium. Now there are two laws regarding this refraction of light. First law says that the incident ray, refracted ray and the normal, incident ray, refracted ray and the normal, at the point of incidence all lies on the same plane. Incident ray, refracted ray and the normal all lies on the same plane. Law number 1. And the law number says that the angle, the sine of angle of incidence, this is the angle of incidence, this is the angle of refraction. The sine of angle of incidence to the sine of angle of refraction is always constant. The ratio of sine of angle of incidence to the sine of angle of refraction is always constant, and this constant is known as refractive index. It is represented by the letter mu. So refractive index, what is refractive index? Refractive index is the ratio of sine of angle of incidence. And if the ray of light passes from medium number 1 and medium number 2, then the refractive index of medium number 2 with respect to medium number 1 will be represented as mu 2 1. Refractive index of medium number 2 with respect to medium number 1, and it is equal to sine I upon sine R. Now if you are having air and other medium, air and glass, air and water, then the refractive index of the second medium with respect to air or with respect to vacuum is known as absolute refractive index. So what is absolute refractive index? Refractive index of the medium with respect to vacuum. Refractive index of the medium with respect to vacuum. Now one more question is there. Why? What is the cause of refraction of light? As I told you in the beginning itself, that the speed changes when the light passes from one medium to another medium. This is the cause. The change of speed of light when it passes from one medium to another medium is known as, this is the cause of refraction of light. So that is the cause. If someone asks what is the cause, change of speed, simple, in two words you can say change of speed is the cause of refraction of light. Now refractive index, absolute refractive index, you can write. So suppose the speed of light in medium number 1, suppose medium number 1 is air or vacuum, then I will represent the speed of light by c. And if this is glass or any medium is there, I will represent the speed by v. Again, the second definition of refractive index is c upon v. That refractive index of medium number 2 with respect to air, or absolute refractive index of medium number 2 is speed of light in vacuum to the speed of light in that medium. Speed of light in vacuum to the speed of light in that medium. For example, if I just want to find the refractive index of, suppose, water, then in case of water, as you know, in case of water the speed is 2.25 into 10 to the power 8 meter per second, and you know the speed of light in vacuum is 3 into 10 to the power 8 meter per second. So refractive index of water will be c upon v. C is 3 into 10 to the power 8 meter and v is 2.25 into 10 to the power 8. When you will divide, you will get 1.33. So refractive index of water is 1.33. Similarly, if you want to find the absolute refractive index of glass, in that case, you know, in case of glass, the speed is 2 into 10 to the power 8 meter per second. Therefore, refractive index of glass will be 3 into 10 to the power 8 divided by 2 into 10 to the power 8. You will be getting 1.5. Yes, 1.5. So refractive index of glass is 1.5. One more thing, you can see the speed of light, the refractive index is the ratio of two similar quantities, whether it is sine of I, sine, or whether it is speed by speed. So two similar quantities are there. The simple ratio, the ratio is there. So ratio of same quantity is there. Therefore, refractive index don't have any unit. Refractive index don't have any unit. Keep it in your mind. If someone asks you what is the unit of refractive index, you will say the refractive index don't have any unit. Why it don't have any unit? Because it is only a simple ratio of two similar physical quantities. So that is why it don't have any refractive index. Now next thing is, what is the importance of refractive index? Refractive index importance is, it will tell you what is the speed of light in one medium and when the light passes from one medium to another medium. For example, you know the refractive index of diamond is 2.41, which means the speed of light in diamond is less, or speed of light in air is 2.41 times greater. Students, in general, if you are having two medium and the speed of light in one medium is v1 and another medium is v2, in that case refractive index of medium number 2 with respect to medium number 1 will be, refractive index of medium number 2 with respect to 1 will be speed of light in medium number 1 divided by speed of light in medium number 2. And as I defined before also, v1 will be mu1 upon c. Similarly, v2 will be mu2 upon c. If you will divide, you will get mu2 upon mu1. So you will be having refractive index of medium number 2 with respect to 1 is mu2 upon mu1. That means refractive index of 2 divided by refractive index of 1. So refractive index of 2 with respect to 1 will be this. So that is the definition. So that in this case you can already, if you are given 2 refractive index here, then you can find refractive index of 2 with respect to 1. You can easily calculate. Now one more thing is there, and that is there if the ray of light passes from rarer to denser medium. For example, suppose the ray, this is the normal, and the ray of light is passing from denser to rarer, then the ray of light will bend toward the normal. If the ray of light passes from rarer to denser, in that case the ray of light will bend toward the normal. And if the ray of light passes, suppose this is the denser medium and this is the rarer medium, denser to rarer, in that case the ray of light will move away from the normal. So two cases are there, rarer to denser toward the normal, denser to rarer away from the normal, and the deviation caused in this case when the ray of light passes from rarer to denser will be delta is equal to I will be greater and R will be less, therefore delta will be I minus R. Here delta stand for deviation. Deviation will be angle of incidence minus angle of refraction. Similarly, if the ray of light is passing from denser to rarer, in that case angle of refraction will be greater and angle of incidence will be less, therefore delta will be R minus I. Deviation will be angle of refraction minus angle of incidence. That is there. So now next thing which I am going to discuss with you is, sometime it is asked, what are the conditions in which the ray of light will not deviate from its path? There are two conditions. Condition number 1 is when the ray of light passes normal to the surface, then it will move undeviated. Condition number 1, the ray of light should pass normal to the surface. In that case, the ray will not deviate. This is the condition number 1. And the condition number 2 is when the refractive index of the two medium, that means medium number 1 and medium number 2 is the same. When the refractive index of the two mediums are same, in that case also the ray of light will not deviate from its path. So these two conditions, sometime this type of question also comes in the examination, gives the condition under which the ray of light will not deviate from its path. So two conditions I have discussed with you. First is when the ray of light passes normal, and the second is when the refractive index of the two mediums are same. In that case also the ray of light will not deviate from its path. That is there. Now I am going to discuss with you the relationship between frequency, speed and wavelength of light. What is the relationship? Now the relationship between the three is V is equal to F lambda. Speed is equal to frequency into wavelength. Now from here you can easily see speed is directly proportional to wavelength. More is the wavelength, more is the speed, less is the wavelength, less will be the speed. So that is there. And one more thing, when the ray of light passes from one medium to another medium, these two factors, factor number 1, factor number 2, that means speed and wavelength changes, but frequency do not change. Now the question is, why frequency don't change? Because frequency don't depend upon the medium, frequency depend upon the source which is producing. So it depends only on the source. That is why the frequency remains constant when the light passes from one medium to another medium. So sometimes this type question is also asked in the examination. Out of speed, frequency and wavelength, which quantity remain unchanged? So that the answer is frequency. And why? I have told you, because frequency depend upon the source. Until the source is same, the frequency will remain same, and when the source changes, only then the frequency will change. It will not change with the medium. That is the student, as I discussed with you that the frequency remains same. So suppose the light is passing from air to other medium. In that case, the frequency is represented by F is equal to C upon lambda, where C is the velocity, lambda is the wavelength. And in the other medium, the frequency will be V upon lambda dash, because the velocity will change and wavelength will also change. So V upon lambda. But the frequency will remain the same in both the case, in air and in medium. Therefore, equating these two things, you will see C upon lambda is equal to V upon lambda dash, which mean lambda dash is equal to V upon C lambda. And you know, refractive index is equal to C upon V, and here you are having V upon C. Therefore, V upon C is 1 upon refractive index. So you can write lambda dash upon refractive index. So this is the relation. Lambda dash is equal to lambda upon refractive index. There is a relation between wavelength and the refractive index, and the relation is reverse relation. So wavelength and refractive index are inversely related with each other. Now what are the various factors which affect the refractive index? First factor is the nature of the medium. Nature means whether the medium is optically denser or whether the medium is optically rarer. If the medium is optically denser, in that case what will happen? The speed will decrease, and you know, if the speed decreasing, refractive index will increase. So in a optically denser medium, the refractive index is more as compared to optically rarer medium. Second factor is the temperature. So when the temperature increases, you know what will happen? The speed will increase, and when the speed is increasing, what will happen? Refractive index will decrease. So temperature increases, speed increases, the refractive index decreases. And the last factor is the color or the wavelength of the light. As I discussed with you, the relation is this: more is the wavelength, less is the refractive index. Less is the wavelength, more is the refractive index. And one more thing, red color of light move faster as compared to violet color. So the maximum speed is of red light and minimum speed is of violet light, and as you know, the relation is reverse. Therefore, refractive index of violet light is more as compared to red light. And the question may be asked in two ways. First is, which color move fastest and which color moves slowest? So fastest color is red and slowest color is violet. Which color has maximum refractive index? Which color has minimum refractive index? Maximum refractive index is of violet and minimum refractive index is of red. Now when I was having the online classes of you people, one question was raised by one student, Prachi, about why red color is having more speed. So beta, this concept is very vast concept. Actually it involves quantum mechanics, but I can just tell you in the language which you can understand in your own words. Now I am having 3 pens. I will show you. Now I am having 3 pens. Similar way, as you know, the light is made up of how many colors? 7 colors. So light is also having 7 colors, like I am having 3 pens. So one pen I intentionally took as red. So, and you know, different colors has different wavelength. So red color is having maximum wavelength. Red color is having maximum wavelength, and then so many colors are there. This is the bundle of colors. When these bundle of colors, suppose you are having this bundle of colors and you are sitting on a car and the car is moving with a speed of 40 km. Okay, so what is happening? These bundle of colors are also moving with the speed of 40 km. Now suppose suddenly an accident takes place. What will happen? This color will strike with the other object, suppose with the other medium. So which color is going to strike first? Which color? I am having these color, you can see. I am holding this. In the beginning, all the colors were moving with the car, but when something come in front, which color will strike first? Red color will strike first. It will penetrate first. It will cover more distance in the surface. And one more thing, since it will cover more distance, the speed will be more. And one more thing, the refraction phenomena is a surface phenomena. It takes place only on the surface of the medium. You can easily see if I draw. Suppose this is the, what happens? The ray of light move and then it bend. Now when it enter in this medium, only bending is only over here, and after this point it moves straight. And again when another medium start, it again bend. So it is bending only at this surface and at this surface. That means only on the surface. So one more concept, the refraction of light is a surface phenomena. I hope this concept is very, you must be understanding this. Color wavelength is more, so this color will hit the surface first. It will just travel more distance inside the. Otherwise, this concept can be explained in terms of quantum mechanics, which I am not going to do. This simple example is, I suppose, is sufficient for you. And even if you are facing some problem, you can just make a comment in the comment section. I will be there to solve your problem. One more concept I just want to discuss with you, and that is, sometimes this question is also asked, whether the absolute refractive index of a medium can have less value less than 1. No, refractive index don't have value less than 1. Then question will ask why. You know, refractive index is mu is equal to, absolute refractive index is c by v, and you know the c is always greater, velocity of light in air is always greater, therefore refractive index is always greater than 1. Absolute refractive index of a medium is always greater than 1. Why? Because the speed of light in air is always more as compared to medium. I hope this session is beneficial for you, and if some flaws are left, I hope you will make a comment. If questions are there, you can just ask me. You are very much free to ask any questions, students. I am here to help you out. So thank you. But before I just leave, subscribe my channel so that you get proper information in a less time. Thank you.